Yeah, back to. Okay, welcome back, everyone. Now we have our panel discussion 2 from the panel discussion series in this conference. For the same, I would like to invite Professor Javier Garcia Martinez from University of Alicante, Professor Huang from KAUST, Professor Rajnish from IIT Madras, Mr. Aman Tandon from Technip Energies, Dr. Chiranjeevi Thota from BPCL India, Dr. Pratik S. Dash from Tata Steel India. So we have all our panelists. Now I would like to invite our moderators for this session, Professor Sonali Das from IIT Bombay and Professor Vivek Polshettiwar from TIFR Mumbai. Okay, over to our moderators.
Okay, good afternoon, everyone. Welcome to panel 2 in CACI, which is about from lab to market, breaking barriers in translating fundamental science. I guess several of us now really want to not only focus our energies in publishing papers, but really want to translate some of our fundamental research into a real technology that help our country to be a self-reliant, to be a Atmanirbhar Bharat. But we also know that there are lots of challenges. There's lots of red tape. There's ideally no system in our country to really do this. At least we, the scientists, struggle like anything. And idea of this panel discussion is to learn from the experts from the industry and academia who are already successful in doing this. So we need to learn how they broke these barriers, how they managed to do this, how they managed to translate some of their fundamental research into a startup or a pilot plant and at a commercial scale. So we already have an exceptional panel of experts today. We have people from industry as well as academia, and not only from India, but also from outside India, where the system, I hope, is better than what we have here. And we want to really learn from them also that how do we improve our system and translate some of our research. With that, I'd like to again introduce the panelists. Again, we're not introducing them in detail because their CV is in your program book so that we save the time. So we have Professor Javier Martinez. He was a former chairman of, former president of IUPAC, and he is not only a great scientist and my collaborator, but he also successfully translated some of his very fundamental research, what he said in his talk, that sometimes you feel that, okay, this is just one of the findings that I will publish and that's it. He clearly said that some of these could be really commercial, has a commercial values. And I think Javier will help us to understand that and we learn from him how he did that. Then we have Professor Huang from King Abdullah University of Science and Technology, KAUST. I spent several years there with Andy. We call him Andy, and we will call you Andy there in this panel. And he is not only, again, a great friend, an excellent scientist, but he also managed to at least attempt to do some of his fundamental research into his trying. Yes. And then I have one of my best friend in Indian academia, Professor Rajnish Kumar from IIT Madras, Chennai. And Rajnish is very vocal. He knows all the issues that we face in our country. And we are trying to write lots of reports, lots of vision documents, although we don't know what will happen to those documents. But we will learn from Rajnish what are the issues and how do we really solve it in an open forum now. Hopefully people will listen to us. Then we have Mr. Aman Tandon. He is an engineer in background, but Aman works in one of the very reputed industry called Technip Energies, and their main expertise is translate the fundamental research in your lab to industry scale. So they act as a bridge between the academia and the real industry, and they have expertise on both the side, from the basic research and the industrial research. And I think we will have a nice input from Aman on this. Then we have Dr. Chiranjeevi Thota. He's a chief R&D in Bharat Petroleum Corporation Limited, BPCL Noida, and we are already collaborating with Dr. Thota. He already translated some of the research in his own lab in BPCL into a BPCL commercial scale. They already have one of the best infrastructure in India, I will say, where you can take that milligram scale processes in your lab and convert that into kilo scale and to a next scale and to a next. So they have a complete lineup, and we already have the experience, and we are going to learn from you how do we do it the same way. And last but not the least, Dr. Pratik Dash from Tata Steel, one of the reputed industry of our country. Tata Industries, we are in a Tata Institute of Fundamental Research, right? Vision of a Tata and Homi Bhabha gave this country a great success in the field of science and education. And Pratik has many experience. He was telling me that he has more than 25 pilot plant already. He taken the research from the lab and translated towards the pilot plant and towards the industry. So I think we have an excellent panel. And now we also have an excellent moderator with me, Professor Sonali Das. She recently joined, maybe 1 year now. Yeah. So she in this phase of a struggling phase to set up the lab, but she also has this vision of not only publishing the paper, but translating her research into an industry. She is an excellent speaker, excellent researcher, and she works in a similar field of heterogeneous catalysis for CO2 conversion. And last week we had a nice 1-day workshop where Nandini was also there, where we try to discuss this in brief, and hopefully today we will discuss this in an open way.
Thanks, Prof. Vivek. So yeah, thank you for including me as a moderator here. So to give like a brief background, so I am someone who started with the industry and then with academia. So I started in the oil and gas industry. I was at UOP Honeywell, which is similar to Technip. We license technologies. We design. I worked as an engineer, so we are already working on already patented technologies. But from there, I got interested into catalysis science, and then I moved into doing a PhD, and then now I do fundamental research on catalysis. Yes. And having worked in both complete, oil and gas, millions of KMTs of, plants, and now I'm looking at nanoscale things. I really struggle that I have seen the two extreme ends. I don't know how to make them meet. Like I know how to make a new catalyst. I have worked on big technologies in the oil and gas plant, but I don't know how to take a new catalyst and go to that level. So I think this panel is a perfect thing that we need for academia today. So how do we make that leap? And I'm really happy to see some of you have actually gone from showing NMR results and then actually taking it to, the industrial level. So I'm very excited to be part of the panel. And yeah, Prof, over to you, Prof.
Yes, thanks, Sonali. So what we will do now, we will have more QA today rather than we speak and keep discussing among us. We will take lots of questions from you, but we'll have 1 or 2 round of brief comments from each of you, and then we will try to open it to the audience. And then we will start with, so it will be 3 to 4 minutes. Please try to keep a time, right? Otherwise, don't mind if I stop you. So you are free to say whatever you want to say based on this topic. We'll start with Rajnish, and Rajnish, you can also say something more about how we are struggling so that these guys can give us some guidance. How do we do it differently?
Okay, are we struggling?
Are we not?
Okay, I guess one of the question which Vivek asked was, how do you go, and Sonali also touched upon it, how do you go from lab scale to industrial scale? So let's take the point of view of a faculty in any IISc, IIT, TIFR kind of organization. So what I believe is, for the first, in India, I don't know, in Western countries, it's a little different. In India, where you hire faculty for their life, you can't fire them. It's difficult to get hired, but then once you've hired them, you can't fire them. So the question is that how do we basically try to get maximum out of faculty if you are in the admin role? What one method which I keep talking about in my institute is that when a new faculty joins, typically we see 30 years of lifetime. So first 10 years, the faculty is supposed to do really fundamental research, because that is where you will basically build that base. Unless and until you have that base, you will not be able to basically be known in a particular area. And then 10 years down the line, we expect the faculties to graduate into a mode where they are engaging with industry for next 10 years. They are delivering industrial project. And now there is something other in India now, which is called corporate social responsibility. So 10 years you work for industry, and then now you are in your 50s or so, and then this is the time when you should be taking into the role of corporate social responsibility, where there is huge amount of fund which is coming from industry, but these funds typically goes to the society. You have to basically deliver technologies which will be useful for the society. You'll have to implement them. So now 20 years with academic background, with 10 years of academic background, 10 years of industrial background, you are primed to basically go and start contributing to the society. So the next third or the last 10 years of your career, you should be mostly focusing on CSR kind of an activity. So now if you look into this journey of really fundamental to industry to society, I see this 10 years in between when you are working for the industry. One has to always understand that the problem is not in my head. The problem is there with all the industry people. So we have to approach them. We have to understand the problem, because the way we understand our problem is very different. We don't understand the right problem. Since we don't understand the right problem, we don't go for the right solution. So we need to first ask them, bring them on board, and try to understand the problem. And this is what we have done in IIT Madras. We have created consortium, which is called Energy Consortium in the field of decarbonization. So we have 13 such industry partners, right from Technip, who is here. We have Shell, we have Chevron, we have Infosys, we have pretty much, you talk about cement industry, everything is basically covered there. What we ask them to identify 3 problems their industries are facing. So typically we will have some 12 into 3, 36 such problems list with us. And then we go to our faculties and we ask them to submit proposals on these 36 topics. Does not matter. We are not worried about duplicating. We think if there are 5 people working on same problem, it's even better, because that gives these people from industry an opportunity to judge you who is actually better. So every 3 months, these people come and present. And from there, they can basically decide 3 months, 6 months, 9 months down the line, which of the project which they would be really interested in. And the success of this consortium lies in if one of the project industry says that this is one project which we are really interested in, we don't want it to be discussed further in consortium mode. So it comes off the table. And then there is a bilateral discussion, and IP and all other things can, because the focus for them would be to generate IP. The focus for us would to basically for the institute or for my group to get a little bit more funds. So this is how we have been able to basically work with industry. Currently, I think in last 3 years, we have 26 industrial projects running currently. And out of that, 10 of that has gone off the table, and we don't know what they are doing, but they are doing something. So that's how we have been able to work with industry in last 3-4 years.
Yeah, before Andy, you take over, I will just ask a follow-up question to.
Sure.
So Indian academia is there maybe 60 years, 70 years now. And whatever you said is very logical, right? We work in this way. But then why it did not happen? How many real technologies we really develop? Like if we go into a catalytical industry, how many catalysts that we have built by ourselves, developed by ourselves? I think most of the catalysts, almost everything comes from
No. I don't think it is true. I'll tell you, by the way.
Tata can make a comment on that.
Yeah, we will get his comment, but I'll tell you. But before, because this many people, before IIT Madras, I was part of CSIR NCL. For 7 years, I was in CSIR NCL, and I will tell you, CSIR NCL is probably one of the prime reason why so much chemical industries are there in and around Mumbai. Huge amount of processes were developed and was translated to industry. It's just that in between for 20 years, we forgot about all that or not forgot, it was basically termed as, what new you are doing. This is the same thing you are doing has been done already 20 years back. So that knowledge was basically, we missed that knowledge for some 10, 15 years. And this is where it went back into really different direction. But it's not true that CSIR NCL has not done. Huge amount of project has gone out. And most of the chemical industry which see around, if you start going back, you will figure it out that one of the processes were from CSIR NCL.
Okay, we will take comments from Nandini afterwards, Nandini, once we open up. But before, we'll try to mix it up rather than this monotonous way. Dr. Thota, do you want to make a comment about the the catalyst industry in India and how many catalysts, the petrochemicals and these all big industries. Yes, working.
Yeah, Professor Vivek, the question which you asked is very relevant. And also my colleague, this, whatever, he told. I'm very happy to know that, he is having a meetings with 11 industry people and forming a consortium and having discussions and, having proposals on the table. But I think it is, I would like to give my, view, if you allow me.
Yes, yes.
You see, as an industry person, if I look at it, because I had been also traveling and interacting with many of the people, I see that academicians or the researchers who are at institutes or universities, they are mostly they are into this, focused on, publishing in very good, journals and, are, writing patents. But patents very few, but I see mostly they are concentrating on research publications and they take pride out of it. But that is nothing wrong with that. But my as an industry person, my only suggestion or my only view is that that should not be the sole motto. Because yes, we should do basic research and we should try to get more visibility. That is fine. But that should not be the sole motto of the entire research community. And we should think that how many of our ideas we should take into the commercial reality. And number two, you asked me that, and catalysis point of view, Professor Vivek asked that if they know, I forgot your name is
Rajnish Kumar.
Rajnish is also putting his view. We are putting efforts, but Vivek says that where is that, how much of these laboratory formulations translate into the commercial level. But Vivek, I will say that there are certain landmark achievements that happen in catalysis.
Okay.
But in 60 years, the amount of work or the amount of products or the amount of research gone into this commercial translation, that was not happened. But yes, there are landmark things are happened, like reforming catalyst. That is the first reforming catalyst, which was came IPCL Baroda IIP, which was commercialized in MRPL. That is a landmark thing where only UOP is monopoly in that particular thing. But likewise, there are quite few are there, but we should expect more.
Okay. Okay. Over to you, Andy. Thanks.
I'd
yeah,
like a
please.
brief comment. What you said is perfectly correct, that, most of us academicians, we look at, high impact publications, and that doesn't work from the industry perspective. So my question to maybe Professor Martinez or maybe Andy. So we also need to have publications to get recognition. How do you marry the two? How do you make that come together with, a final industrialization as well, and translation as well?
So the first thing I would say is that this valley of death is built on the idea of us versus them. This is what is not working. If we keep talking about academia and industry as two different worlds, the gap, the bridge between these two worlds is not going to be bridged. So how we change that? One way is to finding the right incentives. We respond to publications because that's our incentive. That's how we get promotion and recognition. Same thing for industry. You don't get profits from papers. So the first thing is to make sure that our incentives are aligned, because right now they are not. The other thing I would say is that the person that is actually crossing that valley of death is the entrepreneur. The people who is, I want to say people because it can be male or female, who actually cross the bridge, that have the technical knowledge, but also the entrepreneurial drive to take that to commercialization. And then I want to bank one of these myths, which is how we poor professors get more publications, keep publishing, if now we need to work with industry. First of all, this idea of us versus them is completely wrong. But even with that, the most prolific chemists, the best scientists, are the ones not only with more and better papers, but also the ones launching their own companies. If you go to MIT, Harvard, or Stanford, Those professors are not only the ones pushing the boundaries of science and publishing the best papers, they are founders of companies, because to get funding, to get recognition from your peers, if you have done something which is significant, what better recognition than taking that to the industry? Why did I start a company when I was at MIT? First of all, because the essence of MIT is not having this them versus us atmosphere. We are all here to reinvent the future. That is the idea of MIT. Let's reinvent the future. So all the components, all the incentives are aligned. That's the first one. And the second one, how we transform the future. One is by producing the best science, and the second one is actually doing it. So people in MIT recognize, and many other places recognize, that if we want, and that's why during the first slide in my talk was this sense of urgency, if we think climate change is real, and we have all these challenges, hunger, clean water, if we want to tackle these problems, 2 more papers is not going to make a difference. We need to take it to reality. So once again, get rid of these 2 worlds. It's not them versus us, it's all together. Align incentives. And the other thing I would say for the specific case of India, because it's quite similar in Europe, if professors get permanent positions and you cannot fight them, what kind of people are you attracting in academia? The people who doesn't want to take any risks. So, and now you're asking that people who wants to have a secure job, no risk, I want to have full freedom to take many risks. You're not going to find that there. That's why we need entrepreneurs. And also we need people like you, people with industry background that then move to academia, because that people like you are going to seed in this entrepreneurial spirit into the students, because you know chemistry with a different perspective that people that only has been reading textbooks to teach chemistry. So I think that is important. We need more people crossing that valley. That's what I would say.
Yes. Yes. So I want to ask the same question to Aman, because Aman is someone who is a bridge in this valley of death. So Aman, we need to understand, or we want to understand, what are the challenges that you see in Indian academia versus, because you're also working in the European and UK system. So tell us more, and also tell us what we should do differently, so that what Dr. Thota said, until now there is no translation to a real industry. So what do we do?
I completely agree with the fellow panelists. What you said, let's firstly, collaboration is something that really needs to come into place in a much larger way. If you see in the history, in any successful technology scale up, there have to be 3 actors, and the 3 actors have to work together. The first is the researcher, the next is the engineer, and the last is the one who deploys it on ground, or the implementer. It's the industry partner. And all 3 of these play a very critical role in any technology scale up. With any of these legs not in place, and you probably won't have a very successful scale up on ground. When it concerns research, there are 3 broad phases, I would say. The first is when we do this research, there's a very large focus, I would say, in India especially. It's changing, but a very large focus to only look at the yields, experimental results, and other things. But how many of us actually perform feasibility studies then to look at least preliminary economics and see, is this something that we want to scale up? Is it something that it's competing with other industry processes, alternate processes in the market today? Then the phase after research, and this is the time, again, to your question, publishing papers at this point is nothing wrong. I think it's a very good thing. It gives visibility, gives recognition. It also gives, people like us, it gives people like, BPCL the ability to reach out to you to say, okay, this is of real interest to us. Can you change this or change that, or share this with us? I think after the research phase, you need to move to the development phase. And really, this is when I would say it's the actual valley of death, because reaching TRL 6, when you actually have a working demonstration or pilot, is a challenge. And many of the activities never even make it to this portion of the phase. From an industry and an engineering standpoint, I'm very happy to scale up something from TRL 6 to TRL 9. I know it's quite de-risked, and it's quite viable to do it. The big problem is to scale up from somewhere TRL 3, which is lab scale to TRL6, which is a pilot scale. And in doing this, companies like ourselves definitely support, but it's really also up to the research institutes to push that nothing is left just at the research paper, but more at the pilot level at least, because it can give you a good view to move forward or not. I think the big challenge that I see when I interact with a lot of the R&D facilities today is firstly transparency. There's extreme fear that a large company will take that information and probably not give them due credit. But in these instances, I see it rather lying on a desk in a shelf than taking the risk that entrusting a partner to say, okay, the partner will genuinely give me the credit and work together. And I mean, the intention is all good. There could be few instances where they've not had a good experience, but I think the intention in general is all good. Everyone wants to collaborate. And I think also even within I would say specific bodies. So if you have multiple wings of the same institute, they are all working on the same fundamental research, going through the same challenges. Information exchange, so that you can build on somebody's work rather than replicate the same thing, make the same mistakes, spend the same time. More than cost and anything else, I think it's the time that is challenging. And when industry or companies like us see a timeline of 8, 9, 10 years to develop a technology, the market today is so volatile, especially in the wake of the energy transition, that things are changing on a yearly basis. So people don't have visibility to invest in something that probably will take a 10-year horizon to actually come on ground. So collaboration here is key to rapidly scale. And this can only be done, as I said, with all the three parts of the puzzle together: the industry, the actual implementer, or the one who puts it on ground, the asset owner, and the researcher.
Thank you very much, Aman. So you talked very correctly that we need three players here. We need someone, the researcher, to go from TRL 1 to 3. We need someone in between who takes it to TRL 6, and then someone to scale up 6 to 9. So when we say this, now in academics, often we have, for example, the researcher, and we're trying to collaborate. So we have someone like maybe, let's say BPCL. So we have, again, the two corners, the person in between. Do you suggest that the researcher develops, that group develops a skill to do this, or it is partnering through other collaborators for that?
This is a very good point, Sonali. You see that, expecting the researcher who is, generating the idea, and that expecting him taking it to the commercial level. So is it correct, or whether that person is able to take up, entire, job, and also whether he is having the requisite facilities to take it? Because in research lab, I have seen that people are reporting data with micrograms. But if you look at the commercial reactor, here I would like to share my own story. I'm a researcher from CSIR family. And, during my PhD, I am also like other researchers, mainly concentrated on basic things, doing kinetic studies, generating data, and getting few publications and getting certain openings somewhere. That is the main motto I see in most of the cases. And hardly I have seen there that immediately thinking that into the commercial level. But when I came to this industry, and I have seen BPCL, such a refineries where reactors are 30 to 50 meters height, and catalyst volumes are like 200 tons, 400 tons. And whereas in the lab, I have seen gram and milligram are working, and translating this thing to a commercial reality of 400 tons. It is a mammoth task.
No, but the
No.
question,
Here. No.
valid question. I think Dr. Thota, maybe we can also ask Dr. Dash on this.
Yeah, okay.
That most of the time when we interact with the industry, first question they ask is, can you give us 10 gram? Can you give us 20 gram? This is the first question. And what you said is 100% right. We work in a milligram scale. We don't have expertise, right? We are a chemist. We don't have a facility, and we should not do it because it's not our expertise. But there is a mismatch. The expectation from the industry is very different, and we don't have that expertise. So how do we breach that? That's the main goal of this panel discussion. How do we all know the challenges. Now we have to find out a solution. How do we breach? Why you guys ask us to give us in gram and kg? Why can't you make by yourself?
Yeah, I think a good discussion. So I think I agree with your point, all of my panelists rather. So actually, let me start with the point of view, keeping in mind steel industry, because steel industry, you know, is very hard to abate sector, and almost 7 to 9% of emissions is because of steel industry only. And for every ton of steel, like Rajnish was mentioning, we emit 2.5 tons of carbon dioxide. So we produce more carbon dioxide than steel. So the challenge is, if you want to address, there is no single solution. We need a bouquet of solutions. And if you need a bouquet of solutions, it needs carbon direct avoidance, carbon capture utilization, as well as we need enablers like hydrogen and green energy. And all at scale, at low cost. Now, there is a dilemma for steel industry because India is growing. Infrastructure is going to grow. So obviously, steel industry is going to grow. In Europe in particular, the scenario is different. It is more or less stagnant, okay? Down, rather down, I'm being positive that it is stagnant, okay? So in today, India, we produce around 5% of world steel. We are still the second largest producer of steel after China. But we are producing 5% only. By 2050, we'll be producing 20% of world steel requirement, okay, as per projections. So you can imagine the way we will be growing as a steel industry in India per se. And that comes the paradox or dilemma is with keeping in mind CO2 footprint or net zero target in mind. Because most of the steel industry around the world, you name it, we have taken target by mid of the century net zero. So if you'll consider, exactly. So thank you. So we need to emit more than 1,500 million tons of carbon dioxide. And for that, I think it is more the important now that academic industry needs to collaborate. Because we need a bouquet of solution, first of all. We are talking about only industry and academia, that is not important. We need to develop a whole ecosystem. Ecosystem, I mean to say, industry, fundamental research, right? What you are doing. We need Technip kind of people who can pull us out from the valley of death, help us developing different pilots, demonstrate. We help us failing fast so that we work on alternate solutions. And at the same time, we need vendors or stakeholders, others who can scale up our catalyst, our additives, whatever we have to develop at scale. I have been involved in industry, a lot of trials we have done, like you were mentioning. Going from a lab scale, we synthesize some polymers. Going from that to a higher scale, we need vendor partners because we need big reactors. We need scaling up of the chemicals. Finally, the demonstration of the technology at scale. So we need to talk in totality, holistically, rather than in isolation. In addition to that, we also need to keep in mind all the statutory regulatory body as well as governments, agencies, everyone into the loop, so that the funding needs to come for the right project at the right time, so that people need to fail fast. So that succeed, fail fast to succeed. That is what is called. So
just to interject. So why are we always asking for funding from the government? Why can't industry invest more in this particular aspect of bridging the fundamental
that's
science?
a good question, Vivek. Just let me tell you, give me some numbers. Okay. Now, Tata Steel, we are at 20 million ton. We want to become, let us say, reduce to net zero. Then we need to capture around at 20 million ton, 100 million tons of carbon dioxide. Now, 100 million tons, let me take one example that I want to, we'll be producing, let us say, methanol out of it, using hydrogen. So we'll be producing methanol out of hydrogen for 100 million ton. Around 72 million tons of methanol can be produced at around 14 to 15 million tons of hydrogen. Okay, that is the numbers, ballpark numbers. Now, for that 72 million ton methanol, the requirement of world is 2050 will be 350 million tons. So 1/5 of the methanol that Tata Steel will produce has to be consumed by the world. Okay. Second is 14 million ton. Indian projection is only 55 million ton. More importantly, it needs huge amount of energy, almost 40 gigawatt hour. So that will need all Mumbai, Delhi, Calcutta, Madras together into two. The most important aspect is for this producing this methanol, we need $200 billion investment. Okay. And let me tell you, 14 million ton of steel for $1 million steel production, only $1 billion is required.
Okay, yeah.
And
So
for
we
this
will-
capturing, we need $200 billion. So where from the money will come? That part also need to be taken into account. At the end, industry need to survive and give something back to the, so that they will struggle to give even salaries and give back to the nation, because all the CSR, everything will stop. So it needs to be a whole, all need to work together. Rather, a single solution will not. That's why I'm telling single solution will not solve the problem.
Okay, it should be some sort of a hybrid model. So I will go to Andy first, because Andy, you're trying to do this. So
I was
after
trying
listening
to
everyone,
hide.
I'm
I was trying to hide
confused.
myself.
How do we proceed as a professor? Now you are a professor and you're also trying to do this. So tell us how this is happening in KAUST.
Yeah. So hello everyone. I came back from yesterday's panel. Yeah. So I first of all, Vivek, thank you for inviting me. I think I'm here to share more experience about how I struggle in this journey, because I would say I'm still quite far away from the conventional success, but at least through this journey, I have learned some things, and then maybe this opportunity I can share. And I agree with all the comments that the panelists, my fellow colleagues have shared. And first of all, let me point out something that I think it is unrealistic to think that every single faculty member would want to translate their research, or every single piece of the research result should be translated. So I think in that regard, it is totally fine if our faculty colleagues decided, to just focus on education, teaching, and research, because education is certainly one of the most important pillars in higher education. And only when we can do great education, we can inspire innovation, and altogether we achieve some sort of academic excellence, and that can inspire, other business developments. So in that regard, maybe this is just a proposal. Maybe the leadership can consider if funding is available, maybe in the universities or research universities, they can establish some positions like professor of practice, professor of translational R&D, so that there you have some faculty members that have very clear role to also assist other colleagues who are interested but has less experience in translation, and to promote this. Because we know if you want to focus on translation research, obviously you will publish less. And if you are assistant professor, you are associate professor, it's probably difficult for you to get promotion, right? And then people always say, okay, yeah, when you are young, when you're assistant professor, junior, associate professor, you should focus on your research, just focus on your publication so that you can get promoted. And once you are promoted to professor, you can start to think about how to translate your research. But most of people, actually, once you get promoted from this conventional process, you develop inertia. Okay, maybe I can survive this, so I will continue to survive this way. So maybe this is something that we can think about. And regarding the relationship between academia and industry, I think that, of course, communication is important. So the communication would be built upon successful establishment of relationship. So you have to start with making friends, maybe start with some small projects that is maybe insignificant. And once you establish this trust between all parties, you can really discuss the pain points that the industry partners are facing. Then at that time, we may be able to use our knowledge to propose some approaches. Then the two parties can work together. But of course, apart from that, there's also possibility that we may develop something that is totally innovative. And that part is even more difficult, because you have to communicate, you have to try to, allow me to use the word, educate the market. For example, mRNA vaccine. I think before pandemic, probably most of us were not aware of the existence of this technology. So something like that would require, I think, really some determination. And these will, I would say, these will be largely based on the environment and atmosphere, and whether the institution or government can provide a proper support so that a given faculty member will feel comfortable. I think this is something I should pursue, but I also feel comfortable that when I do this, I can expect to receive some support. Maybe I will stop here, and later, if we have some specific question, we
that's
can
a very valid
discuss.
point. I hope some of our academic leaders listen to you and provide that support. And I also agree, one of the very key point that you made is creating a relationship between the academia and the industry. Like me and Dr. Thota became a friend, and then we started collaborating via CO2 India network. So that's one of the idea of a CO2 India network is exactly this, creating. Now we are, I'm connected with Pratik. I think I think, and you are saying that this is what you are doing at KAUST successfully. So before we open it for a QA, I will take a short, brief comment from Rajnish and Javier, and then we open it for the QA.
Sure. One more question.
Yes,
but,
you can ask
I'll
one, and then yeah.
But first, we'll take your comments.
Comment on what, by the way?
On the discussion.
Okay.
If you want to.
Yeah, I'll stick to what I was trying to say. See, I'll give you again the example of CSIR and CL, because this is one of the very clear, they were the leader at some point of time. And when they were the leader, they had 350 faculties. That was not important. What was important that they had 700 technical staff. Okay,
Just
today.
Which year this was? Which year?
This for 25, 30 years almost. It's not, there is a book written on it. You can basically read through it. See, this technical staff, today, what is the strength? Roughly 100 and no technical staff. What do you expect the PhD student to deliver TRL 4, 5, 6, and 7?
No.
See, industry don't understand. In government organization, there is no technical staff. You expect us to do things which we are not trained to do. Our PhD student, you don't hire. We can train PhD student to do that. But then none of the industry hires PhD student in India. Our students goes for AI and ML because they know that they will get a job. See, this is the reality. If I am not able to train the students who are going to take the job, what is the benefit for them to basically do this kind of project? And if there is no benefit for them, they will not take this kind of project. So if they don't take it, then you will never be able to get this kind of people, and we will never be able to deliver it. So I think what we did in those 20-25 years was a very good example that if you have the leadership in terms of scientific leadership, and you have the technical staff to deliver on those leadership ideas, you will be able to deliver. But in between, for 20 years, we stopped hiring, and now there is no technical staff. Talk about in TIFR. Do you have any technical staff who will be able to deliver this kind of project? No. How you will deliver this? If you do not have the human resource, who is going to work? Means I am a single person. If I am doing 5 projects, I need 10 people to work on those projects. And if I do not have that 10 person around me, how we will deliver? Most of the best student actually leave the country. This is still the fact. And we are really with such a one of the most populous country, but we do not have human resource to work with basically. This is a challenge, and unless and until we sort this problem of human resource, I don't think we will be able to deliver. We can have all the good ideas, bright ideas, but if there is no person to work on those ideas, how you are going to deliver that?
Yes. Okay. You want to ask?
So I have coming back to the point of communication between industry and academia, right? I completely agree that there should be a connection first, and then there should be open communication from both ends. But I would like to ask, how open is the industry in communicating their exact needs to academia? When I say exact needs, I'm sure we can have problem statements coming from the industry. And at IIT Bombay, we also have a consortium with all the oil and gas companies where we elicit problem statements from them. But what we sometimes struggle with is that we get a broad statement. But I'm sure that most of the industries are already doing R&D at their end. And they have reached, in many cases, beyond us, right? And they have very clear understanding of this is where we are and this is where we need to go. But we don't often get that information directly. Is there a barrier, or is that in our mind?
Is a very good question. But Sonali, as you rightly pointed out, if you look at 30 years, 40 years back, if I will give only oil and gas sector, there is only one R&D center, that is Indian Institute of Petroleum Dehradun. That is only catering to the entire country and all these OMCs. All projects given to the IIP, IIP is giving solutions to all these people. But over a period of time, IOC has got its own R&D center, HPCL has come up with one center, and BPCL is having its own R&D center. And as you rightly pointed out, we had got all our own systems and manpower, and we know what are all our problems. And nowadays, you know that there is a lot of competition. All three OMCs, they won't discuss among themselves. Okay, because such a type of competition is going on. So in that scenario, I don't know that whether those people will come to you and share their problems or their solutions to you. That is one thing. But here I would like to bring it to the attention of everybody that a good thing happened, that COEZ, a Center of Excellence in oil and gas sector, it was opened at IIT Bombay, thanks to the efforts by the ministry and others. Because of that, all OMCs were together and IIT Bombay, where we are coming and sharing our problems, as well as you are also people coming and sharing your ideas, and where we are picking up and we are working together. Like Vivek pointed out, the friendship or the contact or the coordination or collaboration is, this is becoming one medium where we are interacting a lot. Otherwise, how many times IIT Bombay, our people had come, only after COUZ, these many times we are. And also thanks to Vivek, because CO2 India only I came to know who is Vivek. And after that only I came twice here. Otherwise, I never visited TIFR earlier. So these are all the offshoots, or these are all the things where we have to work upon. By that, it will help us to translate our relations into commercial realities. Means converting these projects. Here, I would like to make one more remark, if you allow me, Vivek.
Quickly.
Here, when I'm talking about micrograms and cases, my fellow panelist Javier, just he laughed and don't discourage. Some comment he made, jokingly I'm telling. Because don't make them darana mat tulonko. That is what he told me. Means in English, what he told, don't discourage. But here, that is one good story also I wanted to, to share with you guys. When I started research, in a Bharat Petroleum Corporation, that is the first batch, no facilities are available. We have created, required infra, and I will tell you that we also started like, you guys only, like grams, micrograms and everything. We started working in that fashion only, but we know how to know, because we know the actual situation. So to reach that point, so what are the aspects which you need to work? So we worked upon those, issues, and finally you will be happy to know that more than 10 catalyst recipes has gone from lab to the commercial scale.
Good, good. I think
and here I would like to tell, Javier, he is a very good, catalyst, and he had his own company. One of the MNC company purchased his company and took his formulation and selling it to the companies. I am one of the person who is buying his recipe.
Wow.
I am one of the person.
Okay. Professor Dr.
But,
Thota,
here you would like to clap me for one more thing. Because of our research efforts, we stopped buying one of the recipe which we are buying earlier. Now we have put our own formulation, our refinery, and we are using it in sustainable basis.
I think that's a great.
That is.
Dr. Thota, let us briefly continue with the QA. I think that's a very good story.
Yeah.
And what you are trying to say is, rather than getting discouraged,
there is a scope.
No even challenge and
there is a
try
scope for
take
that.
on it. I think that's a very good way to approach the problem. Thank you very much for that story. So now, since we have another 30 minutes, I think we
So we'll
open up for the questions. I request everyone to be brief rather than again be philosophical. Right, to ask the question directly, and I ask my panelists also to be more brief so that we can get more questions. We have only 30 minutes left. So you raise your hand, and then okay, we start from Gadi, and then Tez. Yes, and then Dr. It's difficult to see from here.
First of all, I feel...
Yes, I will come to you.
Yeah, first of all, I feel a bit miffed. You started without me, but when I see you replace me with this nice woman, then of course I understand.
Yeah, she's doing a good job.
Yes, I'm sure. So the question that I have is about the support in Indian institutions for researchers who want to start their own companies, because I know in some places like where Javier did in MIT, it's very much encouraged. In some countries, it is sometimes encouraged, but there are all sorts of barriers. Is the feeling that in India is something that is very much encouraged, or yeah, maybe, or is it in some places like this, in some places like that?
Yeah, I think Rajnish can answer.
Yeah, so it depends on institute has autonomy to do whatever they want. I'll tell you about the IIT Madras story. There are 235 startups in IIT Madras. Almost every fourth faculty has a startup. So these are encouraged. Again, if you have made a startup does not mean that it will ultimately become a unicorn. But yeah, there has been at least 10 such unicorn in last few years. And the total research innovation park, which we call research park, is roughly 40,000 crores basically evaluated right now. So valuation is almost 40,000 crore. I don't know what would be the INR divided by roughly 80 in USD. So it's a good way of doing it. Before that, I was in CSIR. I remember in NCL, there were many such startups. But yeah, there is some challenges also. The person who actually went for the startup as per the policy was denied a director position by claiming that you might have taken some businesses away from it.
Yeah,
So these things also actually happens. So this is also, I would like to point it out.
we'll focus on this part right now. Yes, but I think everyone know in the country that IIT Madras, the Chennai, is one of the best examples of translating the research into industry. I think there is no disagreement in that. They have done extremely well, but this is not true in many other institutes, including my own. Right? We are not allowed to start a startup. Even today, 75 years after independence, we are still following the British. I hope people are listening.
The one thing I would say really quickly, MIT was very supported, but one day when I decided to start my company, I left everything with no salary, with no nothing to start my company. That's the thing. If you are an entrepreneur, you need to take risks. You need not to contact the industry, but potential clients, to start with your own business, to talk to investors. So it's not so much about how we collaborate with industry, how they open up projects.
Entrepreneurial knowledge you need for that?
No, I have zero knowledge. What you need, what we are lacking here is courage, no knowledge.
And to be able to knock on doors.
Okay, that's very inspiring. You don't need a knowledge, and we can still start the startup. Courage.
Just a more technical question. So whether you're talking about hydrogen or biomass, all these future chemical industries will be essentially water purifying, purifying more water than making chemicals. So how do you see this aspect about water purification coming into play? And is that really a deal breaker when you talk about real large scale biomass processing, for instance?
I think can you refocus your question to fit into this panel rather than we go to the bio versus solar? I think you can still want to make a comment on it.
Maybe I make a very quick answer. The question is about energy. So water is energy. And then if you talk about water to go with CO2, if you can design a good system, actually the captured CO2 contains enough water. So it's basically the technology and energy issue. And we just need to factor them in the whole process.
Okay. But we come back to today's topic. Sojan Neji, over to you. Sojan Neji. Yeah. Please raise your hand and the mic will come to you.
I'm coming from one of the CSR 37 national lab. It's Indian Institute of Chemical Technology. Basically, it is a chemical sciences lab. As Chiranjeevi mentioned, when they were established to bridge the gap between academia and industry, and there were several technologies were transferred, including paper technology, coal analysis, and so on. But there was a low gap in between because of liberalization, industry liberalization laws. As he mentioned, every industry has their own R&D, so there was no much inclusiveness of CSR. But in recent times, there is a lot of improvement, like adjuvant for co-vaccine, which is indigenous vaccine from India, is from Indian Institute of Chemical Technology. Similarly, several adhesives for Pidilite technology are from IICT. Still, there were some, there are some successful stories, but there is a lot of room. And I just want to make one comment that unlike in Western countries, in India, we have, though we have several billionaires, millionaires in India, we don't get much investment in R&D.
True.
So
Yeah.
Here, I will accept what Madam said. Here, Madam, the answer which I gave to Sonali is that how often R&D, oil R&D is coming to the institutions and sharing your ideas or problems. That is what you told. But you are very correct. Even with IICT, we had quite few projects, like, that biomass reactor. We had a project with them.
It's called AGR.
We are having.
Let us not go into the specifics of the project right now, but what the main point is that the amount of investment the Indian academia expect from the industry is missing. The way it is in other part of the world, it's missing. That's what I also feel strongly, right?
Does the government have some seed fund program that can support at least at the early startup stage?
There are programs, but most of the time it's a software startup, not a deep tech. I don't think there is any good example of a deep tech there.
Get bogged down by
Okay.
release of funds and all.
Yes.
It does not happen in real time and it becomes difficult actually.
That's
You
another-
start
another-
something and
another
then
problem.
you have to just stop and then the funds will come 2 years down the line. These challenges are there actually.
I have a comment to make on what Madam just said. So
Oh, you already have.
I have mine. So what she said is very correct. The CSIR labs have the capability of doing things in the pilot scale. They are actually in that 3 to 6 TRL zone. So should we think of collaborations, more sustainable collaborations between basic fundamental academia such as TIFR, let's say IIT Bombay, where we don't have pilot level things, the CSIR institutes and the industry. Right now, for example, giving the example of COEOG we can only collaborate between the PSUs and IIT Bombay. So we have one extreme fundamentals and the industry. But this triangle kind of a collaboration maybe actually bring all the three.
Sonali, here I would like to bring it your kind attention. Not only COEUG with IIT Bombay, or it is not a specific, we are working with various CSIR labs, whether it is IICT or Institute of Petroleum Dehradun or NCL Pune or CMSR Bhavanagar. These are quite few. We have got quite few projects which we did earlier. We are doing it and we are also planning it.
Perfect. So the idea is to bring three zones together, like fundamental research completely at the microgram level, and then the CSIR labs going to the more scaled up pilot level versions, and then industry.
No, see,
together.
That's
together.
yeah, that's how the CSR was ideally built for that. Obviously, with time they become more PhD granting university than the real
big problem.
Just to
Yeah, let us not go to the
like any
technical,
other academic organization.
but maybe to brief, we'll
Just
take
like
some
I-
brief reply from you, and then Aman also wanted to say something, and then we take another
So,
question.
One point here, actually, ma'am, CSIR, you are telling about that we need to pilot. Probably we are aware or not, we did one piloting at Sekri, which is a CSIR lab, and the pilot is running. Okay, we set up, Tata Steel set up a pilot plant and we operated for 1 year. CSIR, IICT, we have done a couple of projects last year. So we are collaborating with all the CSIR. In fact, a lot of centers are being set now. Earlier, it was kind of a project specific going to different IITs or academic institutions. Now, what we are thinking is we have set up, we must have heard about that, we have got a Center of Excellence at IISM Dhanbad, which is minerals and mineral engineering. Similarly, we are trying to set up different institute at IIT Madras. We have research park. We have got a couple of centers over there where we are working. We have set up not only in India, but abroad as well. We have now our center at Imperial College London
Let's not go
and
into
all
the
the places.
specific.
So
Let's
these are
look
the
at a
different
broader
places
level,
there, but this kind of more center of excellence, basically on program specific. Let us say on CCUS, there can be a center. There can be a center for some other topic. So, or catalyst development, that is what is the need of the day. That is
So
what
you're
is
saying
required.
you're already attempting, and there are
Exactly,
some good
exactly.
examples.
That-
What we are saying is we need more, right? This is as compared to the size of our country and number of researchers that we have. These are very few examples. Before that, I think Aman was trying to say something for a long time. So Aman, can you be brief, and then we take the question?
Just a brief comment on the point that, we have so many billionaires, why don't we have so much investment in India? I think all the billionaire conglomerates, they are spending on R&D, they are spending, no doubt. And we are working on several of those projects, but somehow they are from international institutes. They take technology from overseas. And I think, again, a large part of the reason is also the marketing. They are marketing the technologies from a view of commercialization and with the aim to commercialize. And that is translating for the collaborations overseas. And I think it's changing. There's more and more we are seeing Indian technologies, but at least today, as I see it on paper, all the projects we are doing are more, even in India, are based on international institute collaborations on the technology front.
Yeah, but then this is really important question. Why is that happening? Why Indian industry don't believe in the Indian academia and they run to MIT and
I mean, it's a two-way street, because I've seen so many of the international universities approaching industry with a sales pitch, with a deck, showing them the economics, showing them the process, showing them the technology, and saying, why don't you do this? It's a business case for you. They're making making a business case and coming to industry.
So you're saying we're not able to present our work the
We're
way
not marketing our internal sales enough. If say the same, if an industry comes to you to do it, I'm sure we'll do a better job, if not the same. But we're not able to do it because they're not getting something in their hands. The R&D teams of the industry, they really prefer when they get something, a case study that they can deliberate upon internally. So if you do the reverse, I would say reverse selling, go to them with a case, say, I find this very suitable to your business you operate. It'll make a big difference.
Okay.
One point we are missing.
Can we take a question and then answer that, rather than stretching the same question, right? But that's, I think, very important point. So question there first, yes.
So I am Vipin from ISC. Actually, I have a question about, let's say we develop a prototype for direct air capture for CO2. So when we want to go for, let's say, plant scale or pilot scale, what most we should take care and what assessment we should do before like transition from, like, say, lab scale to the pilot scale?
Anyone from industry? Dr. Thota or Aman? Anyone? Yeah, Andy?
I'm the least qualified, but I'm going to say it anyway. I think a proper life cycle analysis of the energy consumption and then the estimate levelized cost is important. And then this has to be done with a team with the right credential so that the data can be trusted. I think that is probably the first starting point. And if the costs appear to be too high compared to rest of the market existing art, then probably some further improvement will be needed before you go to next step.
Yes, I think this is what Rajnish keeps saying in every committee for the LCA. You want to add something, or we can take just a briefly? Yes. Yeah, please.
Hello. So my name is Nadeem Sheikh. I'm from IIT Bombay. So I have a question, as the panelists have rightly put, that there's a misalignment in goals of academia and industry. So is there a need for implementation of an ecosystem backed by government policy that brings a shifts in the goal of major workforce in the academia, which is the PhD students? Because right now the PhD students are more focused towards getting publications. Is there a need to shift that and to have an alternative bar where they can have a graduation, but not with the traditional bar that we have set, which is, I believe, is a barrier to the translational research?
That's
Thank
a very good question. Maybe Rajnish and Javier, both of you can add. Yeah.
If we want to fundamentally change universities and academia so they are engines of innovation, we need to rethink completely these spaces. So we need incubators. We need to change our chemistry curricula. We need to introduce these things from the very beginning. We need to bring speakers that are good case studies for people so they see it's possible. But it's a fundamental rechange of these institutions physically, in terms of what's happening in the buildings. You go again to MIT, to Stanford, to Oxford. It's not that you have companies in the other side of the town. On campus, you have industrial labs. So today you are doing an experiment here. Tomorrow you are in the company scaling that up. And I don't agree that the problem is the TRL stage or the amount of catalysts. The challenge is the people with the courage to start a company. And that only happens when you create an ecosystem.
I think the question was, say, some institute, if you want to graduate, you have to publish one paper. That's like a minimum eligibility. Can we just replace that one paper eligibility and say, oh, one startup or some sort of a translation, and you still get a PhD degree?
But when again, we are thinking about the rules, you know, how we change the rule, how we get support, but because we don't want to take the risk. What if I become millionaire? Do you think I will care about the next paper?
But what we want here is I want my full security, the security of the one paper, my PhD, when the opportunities become a millionaire.
Yeah, that's
This
the
is
question.
but this is like a joke. If you really believe in making a real change in the world, your paper, your position, all these things are nothing.
No, I think that's very philosophical statement.
No,
If
it's
I
not
was a student, I want to get a degree first, right?
No,
I don't know many people will
I
take
left
a risk
MIT
of-
with 0 papers as a postdoc.
You are one of the good examples.
But then I create a company, because if you want all the security, you're never going to make anything big. That's the thing. At one point, you need.
Yeah.
But I want to echo. I think the ecosystem is so important, because like Rajnish just shared, if for the PhD graduate in the country here, it is difficult for them to find a position in industry. So then if you don't publish, your chance to get a postdoc position abroad is also slim. So I think very important is that the ecosystem need to be established.
Yeah. Thanks, Andy. Prashant.
Yeah. First of all, thank you for interesting discussion and encouraging these technology transfer or to start companies with collaborations. I have one small question. You all know, and we all know, the success rate for a new company, at least in other countries, it's 10%. Probably it's higher here. So what is the exit strategy, or when should someone consider, okay, this thing is not working and I need to move on to something else? This is not being discussed, so I think maybe it's a good thing.
Yes.
I think from a exit strategy point of view, it's really, I think the market feedback and market adoption is going to be the key criteria. And they are very, and again, it boils down to the business case and the fit. So if you look at even the sustainability aspects today, it's always seen as a business. So take, for example, when we talk to companies about carbon capture, nobody looks at, I would say very few people look at the environmental good in terms of removing the carbon dioxide. It's more about, oh, can I convert it to something else and make a profit out of the sale of that product? So it's pure business, and okay, to some extent, everyone's running a business. Everyone wants to see that profitability. It's fine. So in terms of the exit strategy, I think firstly, the development of the process should not reach a phase up to market where when you're building your company or building your project on I would say incorrect or very subsidized economics. But there are still many companies, many technologies today that reach that level, but then they see poor market adoption, so they have to either be shelved or thought about to restart in the future, or completely closed down. So I think to answer your question, there's the only right time is accept it sooner when you have no market adoption, no interest from the industry, and close it as soon as possible, and then work on something and spend your time more efficiently on some, I think, other topic in the space.
Okay, thank you. Mic number 1. Yes.
Sir, the sessions, the discussion was very good, but as an observer, as a student, I had one question is that I had noticed that the translation between academia to
Can you speak loudly?
Sir, I will rephrase it. So the translation between academia to industry somewhere it loses its value in the technical terms, and if the other industry, the fintech industry, for example, if it's more profitable, the investors will go towards that. So how can we pitch that? Like how can we bring a focus to the academic research?
I did not get the question. Can you speak? We were not able to get you a question. Can you briefly, maybe Rajnish?
The question actually is that you might, as an academic person, you might identify certain value to your project or assign certain value to your project, but when it gets scaled up or goes to industry, the value reduces for some reason or other. So how do you basically assess that? Is that the question?
Yes, hopefully.
Yeah, so maybe I'll give it to someone who has already done this. I think for you. Because that would be the first.
So as soon as you think about creating a company, first thing, talk to potential clients. See there is a business case. Don't talk to the industry. Talk to potential clients. See if you can actually market that. What's the cost? What's the cost structure? If you don't have that expertise, talk to people with that kind of expertise. Create a small team. The beauty is that now, even if you don't have the knowledge, we talked about knowledge before, all of that is available on internet. There's a beautiful amount of information about lean startup, how to validate your business case, talk to potential clients, people that will be interested in your product, and don't raise money before making sure that you have a very compelling business case.
Okay, thank you. The last question from, we have many questions, but we have to take only one. I will take it from Bhaskar. Okay, Bhaskar, your mic? No, maybe you take, can you be very brief?
Thank you, Professor Vivek, for bringing this mesmerizing topic of this lab to market. So I actually engaged with a company called Kuo-Wei. It's a Japan-based company. Currently, I'm doing a postdoc in Japan. So I know how, like in Japan, people are working to bring in the laboratory
Can
material.
you please directly brief on the question? We have only 2 minutes left.
Okay, so bringing it to the laboratory to market, they bring one intermediate, just they scale up and finding the potential of the material. I think we need to find in India one intermediate who can just bring it the potential and bringing it to the before the market, they could investigate very carefully the potential of the material.
Yeah,
I think in that case, the professor, my professor, he have been visited 200 companies.
Yes, I got your question. You want someone who helped the professor to interact with the industry, and I think Technip is one of the example. And you want to have any brief comment or?
I think it's agreed. I think again it comes down to communication, collaboration, and working together. So,
yes,
agreed.
Yeah, perfect. Yes, Bhaskar.
Okay. So after listening for an hour, I, as a basic science person, trying to questioning myself, am I here to go from TRL3 to TRL7? Am I meant for it? Or am I a chemist, curiosity-driven research to be done by me, rather than going from the lab to the industry? Okay, I asked this fundamental question because one of the discovery which was done in 1950s by Carl Ziegler is not a planned discovery that actually lead to the market. It was a serendipity. He was going after the reactive metal, and that turned into a polymerization reaction. And the scale-up process is altogether a different ball game, completely done by the industry. It is not actually by the academician. The process optimization is a totally different ball game, where you talk about TRL3 to TRL7 is not really done by the academics.
Okay, so Bhaskar, your point is whether professor should do the TRL3 and above, or it should be someone else, right? That's your question?
In my opinion, there should be a clear distinction between a basic research in terms of the curiosity driven versus, let's say, the lab to market.
Yes, I'm sorry.
Because otherwise, now there is more and more pressure, come from every corner, whether be it actually from the industry, be it from the government, be it from funding agencies. It's all about TRL7.
Bhaskar, sorry to stop you in between because we got limited time. We got your question. So who should do this? Either the professor or industry or a technique.
I'll just make one quick point before passing it on. So you don't need to do it alone, and you're not alone again. And nobody's expecting the PhD student to manage it completely. So there are many spaces. So like internationally, if you see, there are some universities dedicated to support scale-up. Some of the work today that we are doing, say with university, Fraunhofer University, I think the work that IIT Madras is doing, they're trying to bridge this gap. So you have industry support. There are some companies who are dedicated to pilot plants and small scale fabrication who support you. And then there are companies like us who can probably help you with that as well as see it through the end of the value chain. So you need to focus on the core research. But what we say is when don't stop at that TRL, that means you need to push and see it through the end. Not saying do it alone, but try and see that if your research, if you see has market acceptance, has potential, to try and push it through, and you can be a forerunner in that space.
Yeah, I think that's the perfect answer. So I would now request Professor Sonali Das to make a concluding remark.
Thank you, Prof. So thanks to the panel members. It was an excellent discussion, and thanks to all the audience for excellent questions. So one thing I think that we understood from this, that the only way to go from lab to market is through collaboration and connection, right? So we need to be able to collaborate with the industry from the very beginning in deciding what is the agenda, what is it that we want. And then we are not alone in that. We don't expect the academicians to go until the end. We have support, as Aman just said, we have support from vendors who can help take us our work from the lab to slightly higher scales. We have companies who can help us do detailed techno-economic analysis. But probably at the very beginning, we should have a vision in terms of what would be the life cycle analysis, what will be the techno-economics, very crude ideas to understand whether what we are doing will ultimately see the light of day. And then we continuously talk to the industry, and we expect support from the industry as well in being transparent with academia, in telling us what it is that you need from us. And hopefully we hope that the students here would have gotten a little bit inspired from these discussions. And while doing your own research also now, you keep the broader vision in mind.
Yes.
So with that, I again thank all the panelists here. I would like to again reiterate one of the things that was said. Risk taking is perhaps very important. Academicians maybe sometimes don't take that much risk, but if we want to take it from lab to market, then we really need to be courageous, and we have to have that vision. So with that, again, I thank everyone.
Thank you
very much.
Thank you. Wow. Thank you.